Thank you, Bruce, and thank you, Margaret, for the invitation, the opportunity to visit with you. In the limited time that I have today, I do want to share some thoughts with you. And I'm going to share them in the form of concepts that would be applicable across multiple species and, of course, multiple plants that you might be dealing with. I'm going to focus in primarily on those factors that might influence crop livestock systems and high-quality feed options. In the interest of time, I am going to stay close to my notes. There's 6 or 7 items that I want to touch upon to kind of stimulate that, and then hopefully you have our contact information that you can follow up with, maybe more specific questions in the future. This is a broad topic. And I'm going to focus my conversation this morning primarily with ruminant animals, which would be more traditionally thought of as beef cattle, dairy cattle, sheep, and goats. But do realize that concepts would be applicable across other species. Mike will be talking to you about some of the things, pig work in the future. But I want to do it in the light of kind of some of the challenges and limitations that we have. My 35 years of research and experiences, the research projects that we've done, and kind of give you some concepts. Number one that I see, and I heard it mentioned by 2 or 3 people, is urban encroachment. Urban encroachment. Housing and shopping areas development has taken enormous amounts of productive agricultural lands, forcing agriculture into less desirable lands. Along with that is the sale and movement of significant amounts of topsoil into residential areas, to where, yes, it may influence a family raising a little garden or having flower beds, but it is the movement of a potential resource to an area. Yes, these have been successes, but I think it's critical that we consider decisions that preserve quality agricultural lands. The second point, terrain and soil fertility and soil type are very variable across not only this island, but across the state. And in general, because of the harvesting of nutrients out of the soil through the years, our soils now are less nutrient dense than they could be. And being tropical soils, they tend to be very acidic soils as a result, would influence many of our plants. Liming and soil amendments, fertilizers, manures, compost, green waste, nutrients of crops, or rotation of crops are things that could be used in improving the soil quality that we have and improving the productivity of the lands that we have. So urban encroachment is number one. Number two is the terrain and soil type and fertility that we have available to us. I would say the third most important point is that depending on our location, our rainfall, the seasonality of our rainfall, the sporadic rainfall, and the importance of having a soil, as Hector shared with us, the importance of having organic matter in our soil for the retention and preservation of the moisture when it does come. Depending on the location that we may be raising our crops, there might be the opportunity, depending on cost and availability, of some irrigation, or even considering drought-tolerant crops that we're looking at. But we certainly need to be concerned about the water holding capacity of our soils, the water demands of our crop, and where we're placing those in regards to natural rainfall and natural moisture. The fourth point that I want to make is, through my experience, most of all of our tropical grasses and forages grow very rapidly. In fact, when you've got optimum moisture and sunlight, they grow prolifically. And I don't know whether you're aware or not, but if you took most of our grasses, the California grass, Hilo, the elephant grass, or the Napier grass, the Guinea grass, many of these grasses, if you harvest them in 4 weeks of regrowth, the protein level might be 12, 14, 16%. But if you harvest them between 8 and 12 weeks of regrowth, when there's a lot of biomass, the protein level drops down to 4 to 6%. That's not going to yield animal productivity. So we need to balance, understand the chemistry and the change in nutrient density of our plants and manage them for optimum use by our animals. Specifically, the protein as a plant matures. And I would venture to say, I have no experience, but I would venture to say even green beans grown in cool season versus green beans grown in a hot season, that the rate of growth and the nutrient density of that bean would be different with the season. But what we do see in forages is the crude protein and the energy density of that forage drops radically. For a ruminant animal, we need 14 to 16% protein in our diets in order to optimize growth. When we only have 8 to 10%, we're going to just get maintenance, no growth. We limit the animals. In addition to protein and energy dropping, the fiber content of the plant increases. You see, as the plant grows taller, it needs the lignification, it needs the cellulose in order to give rigidity to the plant so the plant can remain upright. But when you have fiber in the plant, it requires the microbial organisms. So our plants, as they get older and taller, become more fibrous. The fiber is only 40% digestible. And as a result, when an animal consumes these fibrous plants, it has gut fill, it limits intake, and the animal productivity goes down. So it's a total management of understanding the plant and realizing the capacity. Now there are some good ideas though. The concept of knowing our grasses, knowing the forage crop that we're using, understanding where they grow best, the conditions, how they grow, understanding the optimum harvest time for those plants, using shorter duration harvest period. You may have heard in the term animals where we use rotation grazing, that we can actually keep the grass at a constant rate. We force the animals to eat all of the grass so that we have minimum weeds in there. You're distributing the manure across. You're minimizing compaction of the soils that we're doing that. And then, although we've demonstrated it can be used, it's not being used commercially. We've demonstrated that our tropical grasses, that corn silage, that alfalfa, when grown here in Hawaii, can be made into very high quality silage and could be fed, otherwise produced during the parts of the year we have maximum productivity and used for animal feeds during the times of the year when you have limited productivity. So it's very key for us. Another option is managing our animals. Using a system. If you go out to the Mealania Research Farm out here in my van, you'll find that the optimization of the grazing system there with the kikuyu grass, they run the young animals in for a few days and let them harvest and select what they want. And then they'll bring in the replacement animals that have a little higher, so that you're moving animals through. And then later on you bring the mature cows in and have them cut down the mass and eat the poorer quality grass and then rotate them out. And so that's just cycling the age of the animal, knowing the nutrient requirements of the animal and how you manage them in the grazing system. So the fourth point was understanding our tropical grasses and how the growing conditions influence them. We've had limited success with legumes here in Hawaii as far as a forage crop. Yes, we've grown alfalfa very successfully in Kohala and experimental plots. We've raised alfalfa on Oahu. In fact, I did dairy and beef feeding studies with alfalfa legume. Some of the challenges that we have with legumes is the establishment, the persistency under grazing or frequent harvesting of those. The competitiveness of our tropical grasses. Whether you know it or not, guinea grass is considered a weed in the pineapple and the sugar industry, and for years they spent millions of dollars trying to control that guinea grass. Well, the guinea grass gets into our legumes, it grows more fast, it shades out the legumes, it mixes in with it, and you don't have a pure crop that you would like. But they are potentially good in the greens. Some of our natural pastures have some natural legume that we need to incorporate. Remember one thing, legumes have a longer recovery period after grazing and harvest. So if they're in a grazing environment, You can't continually go in there and cut it back every 21 days, or the legging's not going to stay within your system. So it requires a concept of management. Yes, the potential. Lucina, where they've harvested. They've actually done it in hedgerows in many areas of the world. Done it in cut and carry systems where you can bring it to the animals. A very high protein feed. But again, if it's left in a grazing system, usually the animals will graze it out and cut it down and kill it, and you'll lose that value of the nitrogen fixation in the soil. The sixth point is the expensive fertilizers and limited local soil amendment production that we have here in the state, and I think Hector commented on that. We need to be more efficient as distribution. We don't have large animal facilities here in Hawaii. Where we have large amounts of manure that could be used as commercial fertilizers, but certainly compost, green manures are an option. Of course, society is concerned about commercial fertilizers, nitrogen, phosphorus, getting into our watersheds, and certainly we need to be more aware of what are the levels in our soil, what are the amounts that we're removing as we remove our crops, and how do we ensure that we replenish, as Hector was saying, maintaining the quality of our soils. Dr. Mathews and I did a study with actually sewage sludge. That's a potential here in Hawaii. Our sewage is really clean compared to many areas of the world where that you've got large industry, where they have heavy metals and things. But that's something. We did a study out of Meolani, and we used sewage sludge as a fertilizer and compared it to commercial fertilizer. And we found that sewage sludge, one application a year, did the same thing as regular applications of commercial fertilizers. And in fact, we had improved nutrient quality of the grass, and we had increased yield of the grass using sewage sludge. Do we want to use sewage sludge in our crops for human food consumption? Maybe not. But certainly there are many areas of land for forage production where you're running them through the microbiota of the ruminant animal, that it could potentially be something that could be used, and also eliminate the other problem we have, how do we handle our sewage from urban areas. So yes, it's a concern. The last point I want to just highlight here is when we look at our goals, what do we really mean by high quality feeds? That's kind of a subjective term, because it's going to make a difference depending on the crop, the animal you're feeding, the age of the animal, and the productivity lands of that. And later this afternoon when we have the breakout session, I'll be there, but there's a lot of byproducts that we've used here in Hawaii very successfully. Let me just hit them. Matte nut press cake, a byproduct of the oil industry for cosmetics. Culled papaya fruit. Do you realize that culled papaya, when it's homogenized, we did rat studies, we did digestibility studies. Culled papaya that's dumped, or in some cases used by cattle or pigs, is equal in protein, actually better in protein and equal in energy to corn grain. And we're looking here in Hawaii at the possibility of converting that into biofuel or energy. It's also an excellent food, but the shortcoming is it's very wet, and it needs to be processed and handled properly. I chopped and ensiled the trees. I tried to do the papaya industry a favor by saying remove the trees rather than just knocking them down and having a period of time. Go in there and harvest the trees. We actually went in, chopped the trees, made silage, added a little protein and some molasses to it, and did digestibility and growth trials with sheep up at Waikea. It's a good feed, but it requires the application. How do we harvest the trees? How do we ensile it? It's a lot of biomass that right now is just being knocked over. A lot of the tree. Spent fruit fry media. The facilities here has been demonstrated. We've demonstrated haymaking is not really an ideal or an optimum here in Hawaii. Our humidity is so high, we cannot get our hays dry enough, so we get mold. So we kind of have to throw out haymaking, but silage making would be it on it. Dehydrated poultry waste and poultry litter. excellent for ruminant animals, because whatever you're using for the mass to absorb the poultry waste, you actually, when you dehydrate it, again, the microorganisms in the cow can actually use the fiber that you're using for the absorbent. And the uric acid that's coming from the feces of the bird and using that. Wheat mill run, byproducts of the flour industry, molasses, garbage. Studies were done on Manoa where we compared garbage coming from hotels versus garbage from the military and demonstrated. But garbage has to be cooked. Garbage has to be processed. But it is a potential source. And by the way, ruminant animals love garbage too. It's not only the pigs. I did a study in American Samoa where we ensiled taro tops. Taking the tops of the taro when they harvest the taro, ensiled it, and we did growth studies and reproductive studies with pigs in American Samoa with taro, and it works. You see, the ensiling process removes the acridity of that taro plant, and so it does not irritate the animals, and it has some potential value. So lots of byproducts. The real question is, what do we mean by quality? How do we isolate it? How much quantity? Because we want uniform consistency of our diets for our animals. We're concerned about the food quality. What's the quality of the product that we're food safety. And then something that we're really not spending time on today would be transport, storage, promotion, and safety. How do we sell our products? So thank you. Just a few concepts, and certainly I'll be around, and if you have questions, I'll be participating in a section on high quality feeds this afternoon.